Hello everyone, welcome to another one of our short talks. Now in this talk we will derive a relationship between the three coordinate direction angles. Okay, so to begin with I will redraw my figure from my previous concept talk. Okay, so coordinate direction angles. Or coordinate angles, they are pretty much the same thing. So these are the angles alpha, beta and gamma. These are the angles made by the tail of a force vector with the positive Cartesian 3D axes. Okay, and so I'm going to draw a figure that I'm going to repeatedly make use of, and our aim is, okay, what is the relationship between alpha, beta and gamma? Okay, so the question, what is the relationship between alpha, beta and gamma? Okay, so to do that I start off by drawing first of all the Cartesian coordinate system. Okay, so here is my vertical axis, my horizontal axis, and then I'm going to complete the figure by drawing the third axis here. Okay, so I'm going to call this as the y-axis. This is my x-axis, and then this is my z-axis. Okay, I'm going to consider a force vector. So here is my force vector. Okay, I'm going to call this vector as vector f. And we know the directions, the unit vectors along I, x, y, and z are I, j, and k. So I'm going to mark them as well with your permission. Okay, so the unit vector here is going to be j. The unit vector along this direction, aligned with the x-axis, is going to be the unit vector I. And the one along the z direction is going to be the unit vector k. Okay, and I'm going to copy this figure because I'm going to be making use of this figure pretty much throughout this concept talk. Okay, so here is what I'm going to do. First of all, on this figure I'm going to mark the coordinate direction angles. What are those creatures? There is this angle which I'm going to be calling as gamma, angle made by the tail of f with the positive z direction. Angle made by the tail of f with the positive y is your angle beta, and then angle made by the tail of vector f with the positive x direction is going to be the angle alpha. Okay, and our aim is, okay, what is the relationship between these three angles? Is it that if I add up alpha, beta and gamma, do I get 360 degrees? Most definitely not. Okay, you'll see that the relationship is quite nice and it's different from what you think it is. Okay, so let me do the following. In order to find out where these angles are, I'm going to draw certain planes and parallel pipettes. Okay, so I'm going to write that down here. Okay, so to find the relationship, to see where the angles lie, we shall draw a cuboid, essentially, or a parallel pipette with the force vector f. Okay, and here is what I'm going to be doing. I'll draw the first one here, and then we'll make use of that to keep continuing to draw the other ones. Okay, so here is the situation. So from the head of this force vector f, I'm going to drop a perpendicular onto the xy plane. Okay, I'm going to copy this line and continue to make use of this. I'm going to complete this rectangle here. Okay, and I'm going to take this force vector f and then bring it out. Maybe I can use it later. Okay, so I'm going to copy that and I'm going to paste that here. Okay, and then let me start doing a few more things to complete this parallel pipette. Okay, we're almost there, and then the last set of lines. Okay, which is pretty nifty, isn't it? This is a pause. This is a situation where I would take a pause and gloat over this to my class, my actual class. All right. So here is the force vector F. I'm going to label that in a different color, right? So this is the force vector F. Okay, and I'm going to copy this figure, and I'm going to draw it at least one more time. Okay, so I'm going to copy that, and I'm going to paste it onto the next page. Okay, so that I'm going to be making use of it in a bit. Let me go back to my previous figure. Now here is what I'm going to do. To find where the angle gamma lies, I'm going to complete a rectangle. Okay, since it's a parallel pipette, all of these are going to be rectangles at any plane that you see. Okay, so if I complete this rectangle here, you will realize that, hey, this angle here is 90 degrees. Likewise, this angle here is also 90 degrees. And where is this little fellow gamma? That person is sitting right here. Okay, and what do you know? We know further that this here is going to be the z component. So with your permission, I'm going to delete or erase this and then redraw it a little in a bit after drawing the force vector fz. Okay, so you'll see that this guy here is the z component of the force vector f. Okay, and I'm going to write them in terms of their magnitude. So I'm going to get rid of this vector f so that I know that these are all magnitudes and their directions are specified by the arrows. So this is going to be fz here, and then you'll see that, okay, hey, this is a right angle triangle, and if I shade that triangle, okay, here, if I shade that triangle which contains the angle alpha, which contains the angle gamma, it is very obvious to see that fz is f times cosine gamma. Okay, let me write the force vector f on here. Okay, so this is the force vector f, and then I can first of all see that fz is equal to f times cosine of gamma. Okay, this is an important relationship, and this is obtained from the shaded triangle. Okay, likewise, I can go ahead and look at the next parallel pipette that I have drawn. I will just let you linger around on this figure here. It's almost as if I took the back face of this parallel pipette and I started rotating it so that I come and join the diagonal elements of the top and the bottom rectangles, okay, to get the angle gamma. So that's on this particular plane. Now, let me go to the next one, and then I'm going to complete a set of planes here, as you'll see very soon. Okay, I'm going to draw these planes which are different from what I drew before, and I'll show all of these figures side by side, and you'll realize that, hey, these are all different ones. And then what I'm going to show is this. Okay, hey, if I look at this creature here, right, which I have just drawn over, this is going to be fy, because that is the component of f along the y direction. And why is that the case? That's because this is a right angle triangle here. This is also a right angle triangle here. And as before, if I just leave it as the magnitude of f without writing the arrow on top, which is completely fine because I know the direction is pointing along what it has been drawn, then you will realize that, hey, where is this angle beta? The angle beta is sitting right here. Okay, and I have another right angle triangle which I'm going to shade. Okay, and with your permission, I can probably take this guy and write him underneath here. Okay, so this is going to be fy, which means that f and fy and the angle beta are of a right angle triangle, where f is the hypotenuse and fy is one of the sides. Okay, so I can write that here as well. So here, this is the shaded triangle is a right angle triangle. Okay, so it's a right triangle. Okay, and in this triangle, the f is the hypotenuse and gamma is the angle that gives us Fz. Okay, so if I know F and if I know gamma, I can find Fz, or that's typically how it works out. And it's fairly easy to see that if I know F and if I know Fy, I can find, if I know beta, I can find Fy, right? Which means that in this situation, I want to go back to my usual colors. So in this situation, you can see that Fy is actually F times cosine beta. Okay, this is obtained from the shaded triangle, right? Triangle. Okay, and likewise, I'm not going to do that derivation here. Okay, so likewise, one can get Fx is equal to F times cosine of alpha. Okay, I'm not showing that derivation here, but I'll be showing this in my elaborate notes. Okay, so will be shown in the elaborate notes, but same idea as above figures. All right, so which tells you that if I copy these figures and I put them side by side, right? You look at this figure here. Okay, so I'm copying that and I'm pasting that here. So that's one set of angle, and let me, for the sake of my sanity, let me get rid of that. Okay, then let me bring this creature here. Okay, if I copy that and if I paste that right next to it here. Okay, you can see that the angle beta and gamma are on different planes. Okay, and likewise the angle alpha. Okay, so it is obvious that beta and gamma and alpha are all on different planes. Okay, and so what am I going to do? I still haven't obtained a relationship between these angles, right? So here is what I'm going to do. So far we know now that Fx is F cosine alpha, Fy is F cosine beta, and then Fz is F cosine gamma. This is the first set that we know. We also know vector F is Fx square, Fy square, Fz square, square root of that. So what am I going to do? I'm going to substitute for Fx, Fy and Fz in here. Okay, so what I'm going to do is substitute for Fx, Fy, Fz in terms of alpha, beta and gamma. Okay, so here is what I'm going to get, which tells me that the force vector F is Fx square, which is F cosine alpha square. Fy square is F cosine beta square. Fz square is F cosine gamma square. All of these to the power half, or I can square both sides. Okay, and then I can say that, okay, F square is, you'll see that F is a common factor inside the brackets, so that's going to be F square times cos square alpha, cos square beta, cos square gamma. And it's quite obvious to see that this F is going to cancel off with that F, which will give me a very beautiful relationship. This tells me that cos square alpha, cos square beta, cos square gamma is equal to 1. I'm going to put a box around this very nice relationship, okay? Because this is something that you're going to be making use of when you're solving problems. And I would suggest that you remember this particular equation, okay? So remember this equation. And what is a nice thing about this equation is that if I know two of the coordinate direction angles, I can find the third one. Okay, so using the above equation, when I say above, I mean that if we know two of the coordinate direction angles, then we can find the third. That is the beauty of this relationship, okay? And this is the only relationship between alpha, beta, and gamma, okay? And please remember this equation, and also remember the fact that they're all on different planes, okay? So I want to underline this, okay? So they're all on different planes. This was a statement that I made in the previous short concept talk, okay? And this is the reason for that is by means of these figures that I've just drawn out here. All right, all of you stay safe, but in the meantime also remember this particular equation, and I'll see you in the next talk. All right, thank you very much.